According to the National Electrical Code, specifically Section 240.3, conductors leaving a 100 amp fuse disconnect must be rated for at least 100 amps. In the described situation, 12 American wire gauge conductors are being used, which are typically rated for 20 amps depending on the insulation type and installation conditions. This is a clear violation of the code because the conductor's ampacity is significantly lower than the rating of the overcurrent protection device, in this case, the 100 amp fuses. Now, let's discuss the 10-foot and 25-foot tap rules found in NEC section 240.21. And A. These rules permit the use of smaller conductors for a limited portion of a circuit's length. This limited portion is referred to as a tap. The intent behind these rules is to allow for short runs of smaller conductors to supply specific loads, provided certain conditions are met to ensure safety and prevent overcurrent situations. Firstly, let's consider the 10-foot tap rule as outlined in NEC 240.21a. This rule allows for a tap conductor to be up to 10 feet long without requiring overcurrent protection at the tap point if the following conditions are met. 1. The ampacity of the tap conductor must be at least the calculated load it serves. 2. The tap conductor's ampacity must not be less than 1/10 of the rating of the overcurrent device protecting the circuit from which the tap is taken. 3. The tap conductor must be enclosed in a raceway, such as electrical metallic tubing or EMT, or otherwise protected from physical damage. 4. The tap conductor must not extend beyond the equipment it supplies. Now, let's consider the 25-foot tap rule as outlined in NEC 240.21. This rule allows for a tap conductor to be up to 25 feet long without requiring overcurrent protection at the tap point if the following conditions are met. 1. The ampacity of the tap conductor must be at least 1/3 of the rating of the overcurrent device protecting the circuit from which the tap is taken. 2. The tap conductor terminates in a single circuit breaker or a set of fuses rated not more than the ampacity of the tap conductor. 3. The tap conductor is protected from physical damage and is installed in a raceway, such as EMT. In the scenario described, the machinery being supplied is located more than 25 feet from the 100 amp fuse disconnect. This means that neither the 10-foot tap rule nor the 25-foot tap rule can be applied to justify the use of 12 American wire gauge conductors. Since the tap length exceeds 25 feet, the use of 12 American wire gauge conductors is not permitted by the NEC, even if they are installed within the EMT. The primary concern here is that a fault or overload in the equipment being supplied could cause the 12 American wire gauge conductors to overheat and potentially cause a fire before the 100 amp fuses at the disconnect operate. To comply with the NEC, several solutions can be implemented. Firstly, the simplest solution is to replace the 12 American wire gauge conductors with larger conductors that are rated for at least 100 amps. According to NEC Table 310.16, which provides ampacity ratings for conductors, an 8 American wire gauge copper conductor with type THHN insulation is typically rated for 45 amps at 75 degrees Celsius. Therefore, to meet the 100 amp requirement, a larger conductor size such as 3 American wire gauge copper or aluminum conductors would be necessary. However, always consult the latest edition of the NEC and any local amendments to ensure accurate conductor sizing based on specific installation conditions and temperature ratings. Secondly, another solution is to limit the length of the taps to within 25 feet and use 12 American wire gauge conductors. This would involve relocating the equipment closer to the 100 amp fuse disconnect or installing an additional overcurrent protection device closer to the equipment. By ensuring that the tap length does not exceed 25 feet and that all other requirements of the 25-foot tap rule are met, the installation can comply with the NEC. Thirdly, an intermediate overcurrent device, such as a fuse disconnect or circuit breaker, could be installed at the point where the tap length exceeds 25 feet. This intermediate overcurrent device would protect the tap conductors, allowing the conductors leaving the 100 amp disconnect to remain 12 American wire gauge, provided that the intermediate overcurrent device is rated appropriately for the 12 American wire gauge conductors. For example, if a 20 amp fuse disconnect or circuit breaker is installed at the point where the tap length exceeds 25 feet, the 12 American wire gauge conductors would be protected from overcurrent situations. In summary, the use of 12 American wire gauge conductors for the taps in the described scenario is a violation of the NEC because the tap length exceeds the allowable limits of the 10-foot and 25-foot tap rules, and the conductors leaving the 100 amp disconnect are not rated for at least 100 amps. To correct this situation, one of the following solutions should be implemented. 1. Replace the 12 American wire gauge conductors with larger conductors that are rated for at least 100 amps. 2. Limit the length of the taps to within 25 feet and ensure that all other requirements of the 25-foot tap rule are met. 3. Install an intermediate overcurrent device at the point where the tap length exceeds 25 feet to protect the tap conductors. By implementing one of these solutions, the electrical installation can be brought into compliance with the NEC, ensuring safety and preventing potential overcurrent situations. It is always recommended to consult with a qualified electrician or electrical engineer to ensure that all electrical work is performed in accordance with the NEC and any local codes or regulations. The NEC is a comprehensive document that provides detailed requirements for electrical installations, and it is essential to have a thorough understanding of the code to ensure the safety and reliability of electrical systems. It is important to note that the information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work.